All right, for the record, the part that you add on and subtract away, let me go back up here real quick. So you see how this is a minus and a plus? See that? That part, that plus or minus, is the margin of error, right? So that bit that you're adding on and subtracting away, that's called the margin of error. But sometimes you will not have to use that formula to find it. Because if they give you the interval, right, half of that interval's length is the margin of error. So it's a lot simpler to calculate it that way if you can. Now, before we get into all of this formula, we're going to need to remind ourselves how to find z alpha over 2. And we learned how to find that back in chapter 7, believe it or not, 7.2. Namely that you need norm inverse. Now, my particular computer does norm dot inverse because I have Excel 2010. But if you don't have Excel 2010, that's okay. You can just use norm inverse and it should be fine. So let's think about this for a second. If you have 90% in the level of confidence, then the area in each tail, you know what, let me get you a picture. Hold on. Okay, so the middle up here is 95%. So let me just write that in. 95%. Oops, it's really tiny. Hold on. Make it big. And okay, there we go. So if the middle is 95%, then what does that leave you in each of the tails, right? So, well, remember that the entire curve, because it's a probability distribution learned in chapter 5, has to add up to 1, right? So 1 minus 95% would be 0.05. So let me do it this way. 1 minus, oh, I even wrote it right up here, look, 1 minus alpha. Okay, so 1 minus alpha is equal, oops, to, I'm doing the 95 one first. I shouldn't be doing that. I should do the 90%. I'm sorry. 90%. Back to this picture. 90. It won't really make any difference to the picture, all things considered, but you know. Okay, so that would mean alpha is equal to 10%, which would be 0.10. Okay, that's the area in both tails put together. So if, there you go, if the center is 90%, then there's 10% left out in the tails. So how much is in each one? That would be alpha divided by 2, which would be 0.10 divided by 2, which would be 0.05. Okay, so there's 0.05 in each tail. And there's 0.10 in both tails. Okay? So let's keep that in mind. This one. All right, so this would be 0.05 in the tail. Okay, so then how do you find the critical value? You do norm inverse 0.05, which would be negative 1.645. I know it by heart, but I'll show you too. Equals norm inverse, or dot inverse if you're mine. Either way, 0.05. What did I do wrong? Oh, my fault. This is the newer version. So mine requires the mean, which is 0, standard deviation, which is 1. Oh no, yours will too. I'm sorry. So any norm inverse will want 0.05, comma 0.1. I forgot about that. And notice it's negative 1.645. And then you can just make it positive because, you know, we don't really need the negative. Okay? So it's giving you the one on the left. So, but since I really wanted the positive one, because it's positive z alpha over 2, I'll just make it positive. But you can figure it out from that. Okay? Or if you really want, you can do 95, because 95 would give you the other one, right? Norm 0.95, comma 0, comma 1. There it is. Why 95, you ask? Well, if you're talking about this one over here on the right, what's to the left of it? 90 plus the 5% over here in the tails, which makes 95. Cool. All right, so I'll be right back here to finish the rest of that table.